Hello everyone. Welcome to the presentation from Sophia Krinner. She is a new business development at the business unit called Warp Knitting at KARL MAYER. And today Sophia will talk about warp knitted solutions for e-textiles. Sophia, over to you.
Thank you, Christoph. Also, welcome to my side. So I'm going to share my presentation with you right away. Can you all see my presentation now? I hope
Looks
so.
looks good.
Perfect, thank you. So talk is about our project TEXTILE-CIRCUIT, warp knitted solution for e-textiles. Our company is called KARL MAYER. Our business is textile machinery. We are a German family-owned business which was founded in 1937. We're still a family-owned business, but we're now operating company with more than 3,000 employees. Our areas of where we're active are warp knitting, technical textiles, warp preparation, flat knitting, and we also offer digital solutions for the textile industry. I want to just dive directly into the area of e-textiles, and I hope I can still finish the talk in the remaining time. So I will try to be a bit quicker. On the next slide, I have put some of the challenges that we see in the area of e-textiles, because when we first started, we thought about why all those products aren't already actively in the market. Why aren't they sold already in a larger number than they are today? So those are just a few examples. I think in the missing standards area, we're making great progress because many people all over the world are working in standardization committees already. Also, the topic of washability, which is really important, especially for smart clothing. Here, people are working on making their own materials more washable, more durable for the washing process. So that's also another area we're really interested in. But if you would click once, please, for me, you can see the areas where we think that we might be able to give a benefit with our technology. So first thing is the high prices. E-textiles have usually higher prices than normal textiles, as there are different materials inside them that cost more money, but also because there are more production steps that need to be done to get the product. So in our case, we try to reduce the number of production steps, and therefore you don't have that many people involved, that many different technologies, that many different plants, and that much different knowledge, and you don't need to transport the goods that much, so you create cheaper products. Also, for the complex production and complex development process, that can be beneficial as we reduce the number of technology included, and that way someone who knows about this technology is already able to do a much bigger part of the development. And a really big thing is the wearing comfort of textiles, because people are used to the clothing they wear, and they don't want to experience something that feels different. And I'm really impressed by what printed electronics and laminated electronics can do, and that they're already so flexible and stretchable. But it's still always a difference between a textile and a laminated sensor. So what we are trying to do is integrate the function already inside the textile and to keep all those textile characteristics. And what you can see now is that we already want to get more customer acceptance for our products by adding all that benefits to the product. So if you go to the next slide, I just want to briefly introduce our technology, because we want to achieve all that with warp knitting, which is basically a combination between weaving and weft knitting, if you want to see it that way, because you have, as you're already seeing in weaving, two yarn systems that are crossing with each other, and in weft knitting you only have one thread that is interlinking with itself to create a fabric. So warp knitting is a combination. As you have a warp,